Hello, and welcome to the mathleague.org YouTube channel. My name is Jolie, and today we will be going over a problem from 12116, a middle school test from 2021. This problem was number 7 on our team round. The problem reads, Sophie is rolling 3 fair 6-sided dice. Given she rolls the numbers A, B, and C in that order, where A is greater than or equal to B and B is greater than or equal to C, what is the probability that B plus C minus A is less than 0? Express your answer as a common fraction. To start us off, let's find the number of possible sets of numbers Sophie could have rolled. We know that A is greater than or equal to B, and B is greater than or equal to C, so we can do casework on A to find the number of possible sets of these 3 numbers. Let's quickly make a little table for the values of A. So, to start, if A is equal to 1, then both B and C must be equal to 1 as well. There are no other possible values for B or C. If A is equal to 2, it still works to have both B and C be equal to 1, because obviously B is less than or equal to 1 when A is 1, so it also has to be less than or equal to 1 if A increases. So the possible values of B and C from when A is equal to 1 carry over to when A is equal to 2. And then we also have 2 more possible sets if B is equal to 2 and C is equal to either 1, or when B is 2 and C is equal to 2. So that's a total of 3 possible sets for this case. So 1, and there are 3 here. And then we could keep on just listing out all these possibilities, but instead we should see that for all of these cases, the values of B and C that worked for the previous case still work, and we also add all of the possible cases when B is equal to A and C is anything from 1 to A. So like in this case, we took over this possible case from the previous case for value of A, and then we also added in all the possible cases for B and C when B is equal to A, which is in this case 2, and C is anything from 1 to A as well. So using that method, we can find all of the possible values in all of these cases. So for 3, we have the original 3 cases from the case where A is equal to 2, and we also had the cases for B and C, B equal to 3 and C equal to 1, 2, or 3. That adds 3 more cases, which for a total of 6. We'll write that down here for a total of 6. For this, we have 6 cases from the case where A is equal to 3, and we also have 4 more cases for a total of 10. 5, we have this 10 plus 5 for 15, and for 6 we have 15, and then 6 more for a total of 21. So altogether we have 1 plus 3 plus 6 plus 15, plus 10 plus 15 plus 21, or 56 possible sets of numbers that Sophie could have rolled. So we're going to write that over here, 56. So now that we have a little bit more space, let's find the number of cases where this quantity B plus C minus A, right here, is less than 0. So again, we're going to do casework based on the value of A. So let's draw out that table again. So again, we're going to do casework based on our value of A, right? Well, the minimum value of B plus C is going to have to be 2, 1 plus 1. So there are no possible cases where A is equal to 1 or 2, where B plus C minus A is going to be less than 0. If A is 3, then the only case that works is the one where B and C are both equal to 1, because 1 plus 1 is 2, 2 minus 3 is negative 1, and that's going to be less than 0. So there's only one case here that works. If A is 4, then the case where both B and C are equal to 1 still satisfies this inequality, and the case where B is equal to 2 and C is equal to 1 also satisfies this inequality for a total of 2 cases. Like in the casework we did earlier to find 56, the values of B and C that worked for the previous case still work, because if B plus C minus A is negative, it's going to stay negative if A gets larger. So all the previous cases still work, and any cases where B and C sum up to exactly 1 less than A also work. So for the case where a is equal to 5, these two cases from the case where a is equal to 4 still work, and there are also two cases where b plus c equals 4, right? So there are these two cases, and then there is the case where b is equal to 3 and c is equal to 1, or when both b and c are equal to 2, for two more possible cases, or a total of 4 possible cases when a is equal to 5. When a is equal to 6, we've got those 4 cases originally, and then we've got 2 more cases where b and c sum to 5. That'll be either when b is equal to 4 and c is equal to 1, or when b is equal to 3 and c is equal to 2. So that adds 2 more cases here for a total of 6 cases when a is equal to 6. So altogether, we have 1 plus 2 plus 4 plus 6, or 13 possible cases that satisfy our inequality. So we have 13 desirable cases out of 56 possible ones, so that gives us a probability of 13 over 56 that Sophie rolls a set of dice that satisfies the inequality b plus c minus a is less than 0. That's what our question is looking for. We don't have any way to simplify this fraction, so our solution is 13 over 56, and we are done. Thank you very much for watching.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.